Hello friends, welcome back. The next optimization technique that we need to learn is pruning. Alright, pruning is a very fascinating method that involves eliminating unnecessary components of a neural network, such as the layers and the connections. That way, we can enhance the efficiency and effectiveness. This is a very nice approach and most preferred approach as well. This technique fundamentally focuses on removing redundant or less important neurons, layers, or connections, that way resulting in more streamlined and more compact model coming in picture. By simplifying the network structure, pruning not only reduces the model size but also improves its most important aspect of the processing speed without sacrificing or compromising the performance. The result is a very leaner, faster neural network that maintains its functionality while shedding the excess weight. It's a very, very important technique and very well preferred technique as well. By kind of eliminating the layers which are additional or unnecessary or the connections that are not required, the models become more streamlined. Thus, it will enhance the inferencing speed. This will result in quicker predictions. Additionally, the process significantly improves the energy efficiency, making it a very ideal solution for mobile devices and embedded applications where power consumption is a very crucial factor. Do we have different type of prunings? Yes, again, there are two types of pruning techniques available. One is weight pruning, second one is neuron pruning. Weight pruning removes less significant weights that are nothing but the connections. Neuron pruning removes entire neurons or filters in a layer. Both the ways we can make the entire neural network very light. We are going to see a very simple example here before pruning and after pruning. You can see that the picture that is presented in front of you has shown how complicated it is before pruning and after pruning how much easier it is. This way the model becomes light. We can take another instance here. We can take a neural network, a deep learning model for an instance consisting of 100 layers. It is likely that numerous neurons within this model contribute very minimally to the final output. So by eliminating about 30% of this less significant neurons, the model can potentially maintain over 95% of its accuracy while operating 40% more efficiently. We are not compromising on the efficiency, we are not compromising on the accuracy, yet we make the model light. That's what is pruning all about. A simple example is always required and we always go with that approach. We are going to see a very simple code where we can understand application of unstructured pruning to enhance the inference speed pre-trained ResNet 18 model using PyTorch. PyTorch is most preferred. Again, we'll have some learning over there as well in the near future. Initially, the model is imported and configured for evaluation while a random tensor is generated to simulate an image for testing purposes. To establish a baseline, inference time is recorded prior to the pruning. Subsequently, the pruning process will be done, which involves setting 30% of the smallest weights to 0 in each convolution layer utilizing the PyTorch pruning tools. We have got a lot of pruning tools available with PyTorch, which are very easy to use. Following the pruning procedure, the inference is executed once more and the time is measured to demonstrate how decreasing the number of active weights accelerates the model execution. We will see the results in front of our eyes. This straightforward pruning technique serves to showcase how model sparsification can boost performance without altering the fundamental structure. Let's go through the code. It's a very simple code and it has got a result which is presented in front of you as well. What is the first step? We'll go ahead with loading the pre-trained ResNet 18 model. Then we can simulate input, which is nothing but a random tensor like an image. And then we will go ahead with inferencing. We will go ahead with understanding what is the inference before pruning. Then we will apply the simple unstructured pruning and we have got techniques available with PyTorch which we are going to use. And we will get 30% of the weights zeroed right away. And then we will understand what is the inference after pruning. So the comparison is presented right away in front of you. The results are very interesting too. Inference time before pruning is 137.74 milliseconds and after pruning is 100.99 milliseconds, which is pretty much effective. You can go ahead and have a look at the code from GitHub link which I have provided. Meanwhile, you can scan the QR code as well to get the complete code right in front of you. You can try it out once in the Google Colab or Intel Tiber AI Cloud. That way you will be able to get the results. Thank you.